Alright, this is the transmission line question. It's very similar to this one every year. It goes from 9 to 15, but in this video I'm just going to go from 9 to 11 and then 12 to 15, otherwise the video will be too long. Alright, this DC generator has a constant output of 500 volts, 500 meters. Each wire has 5 ohms. Then we have some lights, and the current is 20 amps. Another way to look at this, just to draw another diagram, is each of these wires is like this, and then we have our lights at the other end. Okay, so it's just a series circuit. Alright, the power output of the generator, so it's pretty simple to get started. The power VI, 500 volts times 20 amps, and 500 times 20 is 10,000. Alright, the power loss in the transmission lines. Power loss in transmission lines, the formula we like using is I squared R. So 20 squared, so that's the current, 20 amps, and the resistance. Now this is where a few people got this wrong. The resistance, the total power loss in the power lines, well, there's two power lines. Each of the power lines has 5 ohms, 5 and 5, so they're added together because it's in series, there's 10 ohms altogether. So 20 squared is 400 times 10 is 4,000 watts. So the diesel generator here gives off 10,000 watts, and 4,000 watts is used up in the power lines. What's left over for the light bulb? Well, 10,000 minus 4,000 is 6,000. That's going to help us answer the last question. What's the voltage across the terminals of the light tower? So basically, what's the voltage across the light tower? Excuse me. So power used in light tower is equal to our, just what I said before, 10,000 minus 4,000. 10,000 produced by the generator, 4,000 used, there's only 6,000 left. 6,000 watts. So now I've got the power in the lights, that equals the voltage across the lights times the current in the lights. We're asked to find the voltage, so voltage equals, divide both sides by I. 6,000 divided by, what's the current again? Can't remember. 20 amps. And 6,000 divided by 20 is 300 volts.